Hello, let's make a video about electrical calculations. If we've been following along with the project, specialty flooring, we worked on the HVAC and how to calculate all of that. We didn't do the electrical yet, so let's get to that. We're going to start with the calculations first. As always, we'll find a project that's similar and we'll start from there. So I found this project that's office with a big warehouse in the back called Southern Fence. There's a folder there called electrical. So I'm going to copy this folder and I'm going to go back to the specialty flooring folder and I'm going to paste that folder in there. So now we have an electrical folder inside our projects. It says electrical calcs, Southern Fence. I'm going to change that from Southern Fence, specialty flooring. Let's open that spreadsheet to see what's happening in there. So, a whole bunch of stuff. We got to get familiar with Excel. So hopefully the earlier ventilation air calculations help. And so what are we doing here? We're taking all the loads on panel P1. We're going to add them across in watts. We'll get an answer in watts. We'll divide the watts by voltage and phase, and we'll get some number here. These two right here that tell us the size of the panel. How does it work? Well, where do these numbers come from? There's an air handler, there's a heat pump. In our case, for building 1 that has 3 air handlers and 3 heat pumps, we're going to change this and add 2 more heat pumps and 2 more air handlers. So air handler 2, heat pump 2, air handler 3, heat pump 3. We're going to add the total wattage of each one of those pieces of equipment. Then for building, for the main building, there's 2 water heaters. So I'm going to copy this and paste it here. Now notice when I paste it here, this number is going to change. It's going to go up by a little bit because it's adding across as we go along. What else is in there? Well, there's lights, obviously, and we have an allowance for this is the actual size of the building, but here we have an allowance for watts per square foot. We're going to say, in addition to everything that's already connected, we're going to give an allowance for 7.5 watts per square foot. So let's go get these numbers. Air handler 1 and HP 1 actually comes from our mechanical plan. So let's open that. On the schedule sheet for the mechanical plans M001, we're going to see that there's some numbers. Okay, so air handler 1, air handler 2, air handler 3, and their corresponding heat pumps. It says here the air handler uses 58.5 amps. Okay, and then this is the size of the fuse. We're actually not adding fuse sizes. We're adding the actual amps that it uses. So it says 58.5. And over here we'll see the voltage. If it says this reads 208 or 240 volts at single phase. Phase is something how the power is delivered, and it affects the calculations a little bit. It's either one single phase or 3 phase. In this case, they're single phase. So we have 58.5 amps at single phase. So if it's single phase, we'll use the 240 number, 58.5 and 240. Let's go back to the spreadsheet then. So air handler 1 uses, and it's backwards, but it doesn't matter. The previous one uses 53.5, but we said here we're going to use 58.5. Now notice when I enter this number is going to change a little bit. So I hit enter, and it went up just a slightly, very slightly. If I go back to the mechanical sheet, I noticed that all the air handlers are going to use 58.5. 58.5 here for air handler 2, 58.5 here for air handler 3, and 58.5 for air handler 4. I'm going to just copy this across, and you'll see that they all become 14,040. So I'll paste this formula here. I'll paste this formula here. And as soon as I enter the number, well, didn't work. Paste right there. There we go. That number went up a little bit. But there's well, and there's a heat pump and air handler 4, but they're actually in a different building, not a building served by panel 1. Okay. So that's it. Now let's do the heat pumps then. 240, the previous project used 18.5 amps, but this one actually uses something else. And that number is based on the size of the piece of equipment. So the heat pumps use 30.1. Air handler 2, I'm sorry, heat pump 1, heat pump 2, and heat pump 3. This one's in a different building, so this side here is served by panel P5, which is the warehouse building and specialty flooring. So let's enter 30.1. It's single phase, and so if it's single phase, we use 240. Back to the spreadsheet. While I was talking, I forgot what it said. 30.1. So 240 times 30.1. That 429 goes up a little bit, and they're all the same. So heat pump, right? Paste here and paste here. What else is in there? Well, if there was a kitchen, I have already built in here. It adds up all the kitchen equipment and spits out a number here. When I say kitchen, I mean a restaurant kitchen. And I could say, for instance, I'm going to slide these over here. Put them right there. When you cut and then paste, it brings the formula along with it. And something happened here. We'll fix that in a minute. So I could say kitchen here, and I could make the value of this cell equal the value of that cell. So when we go here, there's a formula there that says equal the value of G48. Let's say we start entering numbers here. 1 and then 1, and you see it starts adding them because that number becomes 2. And so every time this changes, this will change. We don't have a kitchen. That's what we use for a restaurant. So we're going to have a kitchen here. So we'll put all these back at 0. We have 2 water heaters. So where do we get this information? Well, we go to the plumbing plan where the schedules are for water heaters. And we'll open the schedule sheet, which is the first one on the list of plumbing sheets. So we'll go there. And what does it say? And the water heaters, here's the thing about water heaters. It tells us 25 amps. But 25, 25, 25, 25, 25. Let's see if that's correct. Okay, so here's what's happening. It's 3,000 watts, 3.0 kilowatts. If we divide that by 120, we get amps. Volts times amps equals watts. That's some physics formula. Volts times amps equals watts. So if we multiply 25 times 120, we're going to get 3,000. Okay. The spreadsheet works in watts. So we can just plug that number right out of here. We don't have to do the multiplication. We just enter 3,000 there. So here they are, water heater 1, water heater 2. There's a water heater 3, but it's in a separate building served by panel P5, which we haven't calculated yet. So it takes 3,000, and this one takes 3,000 as well. We could do the other way. We could make a formula that says equal 120 volts times 25, and we'd also get 3,000. But there's no need to do a formula here because when we buy a water heater, we'll know its wattage. We're adding across. Lights. Well, it's a simple calculation. Remember when we did HVAC calculations, we said we're putting 1 watt per square foot, right? So if we take the entire area of our space, and we'll go from here. Well, you know what? Actually, that's not going to work because there's a little bump out. So let's do a polyline around the entire perimeter of the building. And we'll just follow along with the exterior wall. And we come back to here. And we'll go perpendicular to this side of the wall. Perpendicular to there. And then we'll go straight across. And I think if we start on the top, we can hit C for close. Or we can just click on the input. I like hitting C. And that's the area. I'm going to change the layer of that to RefCloud, which is a layer, whoops, what did I do there? Which is a layer that I don't plot. I'm going to move it out of the way so I can see it here. And I'm going to list this. Well, the square footage is 6,113. So if I put lights, 6,113, which is equal to the square footage of the building, 6,130. Sometimes I do a formula here that will say this equals the value of the square footage cell times, in our case, 1. It seems like a silly formula, right? Because 6113 times 1 is 6113. Sometimes we're not allowed to have a whole watt per square foot. We can only have half. So then the formula will vary. In this case, is 1. So notice the number would be going up. Now what's happening here is we're going to add all these numbers across here except that one. Because that's not a calculation. This is a watts per square foot. I was smart. I would take this number out. Let's do that. I'm going to just revise my formula on the fly here. Square feet. I'm going to tab over to here because what happens, this word was longer than this box, so I'm going to start putting numbers here. So this is 6113. I'm just going to take that out of here. So what happens here is lights equals 1 times the value of this cell instead. So that's now N9. Okay, N9. And this is a little bit of calculating a little bit of Excel. So now lights, and then I already know the square footage. So watts per square footage. Some allowance we're allowed to have, in this case for that particular building, was 7.5 times watts, 7.5 times the square footage. And that gives us a number. Like I said, everything connected plus 7.5 watts of power per square foot. That's a little high for something that's a warehouse and there's not anything plugged in. So I'm going to change this cell. This cell should be, instead of N3, it should be N9. 9. There it is. And so it changes to blue and it highlights the cell in the same color. If there's multiple cells, there'll be different colors, and the cell is talking about will change to that color. So what are we doing here is adding across. B3 plus C3 plus D3 plus E3 plus F3 plus G, and that's, it kind of freaked out here, plus G plus H plus I plus J. Let's add J3 here. You can click on the cell or just enter the number. And it highlighted J, K, L, M, N, N3, O3. So it's adding across. Put the lights right next to it. It might freak out again. There it was, freaked out again. So B, C, D, E, F, G, H, I, J, K, L, M3. M3 plus N3 plus O3. Enter. And added that. So what does that mean? This is the calculated value. So it adds across. It says in this building I'm using 121,753 watts. How do we convert that to service size? Well, we divide this number by the voltage, which in our case, I think we said, and this is a number I'll give you, single phase or three phase. So I can enter three phase here, and the calculations will change. It says we're using 338 watts of power, but the code says you have to oversize it by 25%. So when we get this number, we have to multiply it by 1.25, and this is the size of the electrical panel. In actuality, that 7.5, and it says here that I need 423 amps at three phase, but they don't make that, so I'm gonna have to buy a 600 amp panel. I'm gonna do my best to get this under 400. And in reality, we really don't need 7.5 watts per square foot because there's just gonna be, we're not gonna plug that many things in because it's a furniture place. So even 5 is high, but I'm gonna change it to 5, see if we can get that under 400, and we did. So this is the size of the electrical panel. 370, which they don't make it 370, but we can buy a 400 amp panel. We put a 400 amp fuse, and then we're good to go. So this is, here's what happens. if it's single phase, the multiplier becomes 1.73, which is the square root of 3, and the voltage becomes 208. If I change this to single phase, the multiplier becomes 1, and the voltage becomes 240. So let's change that real quick and see how quickly that goes up, because we're dividing by 1 or we're dividing 1.73. If I change that to 1, it almost doubles it, 555. And like I said, the multiplier changes to 1 and the voltage changes to 240. And these, how it does that is I have all I have to enter here. All I have to enter here is a 1, and this is an if function. It says if the value of this cell is 1, spit me out a 1. If the value of this cell is 3, spit me out a 1.73. And then if the value of this cell is 1, spit me out a 240. And then if the value of this is 3, spit me out a 208. So 208, 240. If the value of this cell is 3, give me 208. Otherwise, give me 240. It's 3, so it's giving me a 208. So I take these numbers and I use it for the division here. This is watts. We'll divide it by volts and phase to get amps. So here it's we divide it by 208, and we also divide by 1.73, so it gives me the 296. And then we take this number and multiply it by 1.25, which by code we have to oversize by 25%, and I get this number. All these formulas are basically figured in. I just wanted you to see how that works out. We just got to be able to put information here. It'll calculate the total. It'll divide by the voltage in the phase, and it'll give me the connected amps, and then it'll give me the size of the panel. So what's happening here? The heating, this is just for information here. I'm adding the total of the air handlers, but since I have 3 air handlers, I'm going to have to add F3. So it says here I'm using 157 amps for heating. Okay, and for air conditioning, it says C, E, and G. So I'm going to have to add G. Sorry, that's G3. And it says, I'm sorry, it says that I'm using a total of 177 amps for air conditioning. Electric water heaters, actually I have 2. I have H3, cells H3 plus cell I3. So 3 plus 3 is 6, that makes sense. For lights, it basically equals the value of this number, whatever that is. So if I change this to 8, that should change to 8, and it does. I'm going to undo it. For receptacles, this is the receptacle load for just convenient stuff, right? It's the same number as this. For kitchen, what does it say equals H3? Well, it's actually J3. Should be 0 because there's no kitchen, right? And then lights and receptacles, it adds the lights, the receptacles, and even the kitchen because that's kind of light and receptacle load. And then, of course, have to put one here that's bar if we want to have a separate panel for the bar. So let's say I'm going to copy this formula and I'm going to move it here right under where I would put the bar equipment. So B38 bar equals the value of the cell B38. Of course, there's no bar, but I could add coolers and I could add all kinds of things, right? And then it'll give me the sum. This formula gives me the sum of everything above it. That's bar related. And this formula gives me the everything that's above it. That's kitchen related. There's no bar and no kitchen. Sometimes I just delete these because they don't apply and it kind of confuses things. But here we are. We added air handler 1 and heat pump 1, air handler 2 and heat pump 2. We added air handler 3 and heat pump 3, and we get that information from the first sheet and the mechanical set of sheets. The air handler amps and the heat pump amps. Then we added the water heaters. We get that information from the first sheet and the plumbing set, which is P001, and as many water heaters as there is. We can take the amps and volts, but like I said, water heaters, we know what the wattage is because that's how you buy it. You buy a 3.0 kW water heater. Water heater, not hot water heater. If it was hot water heater, we wouldn't need it because the water is already hot. A lot of people say hot water heater. It's redundant. So anyways, we get the information from the water heater here, and we punch it into our spreadsheet. Kitchen, we get that information from the kitchen equipment. We'd find out how much amps a refrigerator uses. We'll multiply times its voltage, which is usually 120, and we get a number here that will be populated up here by the formula. And same with the bar. So now we know we need a 400 amp electrical panel for this building at 208 volts and 3-phase power. That concludes video number 1 for the electrical calculations and the electrical. Well, there's only one video for the electrical calculations, but this is a video number 1 of the electrical series.